Hello, everybody. I welcome you to my talk today about trending web performance practices. My partner in crime, Tijana, is unfortunately sick today, so she planned to do the practical part today. But so today I will tell you a lot of theoretical stuff only about trending web performance practices, but you will not leave this room without knowing anything new about it, so don't be afraid. How do I come to do a talk about web performance? I was with Tijana, who is also working at AppCont with me at the Script 19 previous November. And one day prior, there was a full-day workshop with Harry Roberts, who is also called at Twitter CSS Wizardry. Does anyone know Harry Roberts? Oh, nice, quite some people. He's a web performance expert overall, and he taught us a full day just web performance. It was really interesting, but I thought I want to give in a small format what I learned in this meetup to you guys. So overall, what is first the importance of performance? I think every one of you know why web performance is important, because we all know the struggle of a very slow website, right? And we have to see web performance also from the business side of the spectrum, because when we look at wpostats.com, you can see case studies and experiments demonstrating the impact of web performance optimization on user experience and business metrics. And here you can see quite some nice information out there, what some popular companies achieved with investing in performance. For example, Netflix saw a 43% decrease in the bandwidth bill after turning on gzip alone. Or GQ cut load time by 80% and saw an 80% increase in traffic. Median time spent on the site also increased by 32%. So overall, it really pays off to invest in performance. What does performance have to do with morality? Well, of course, we can access websites pretty good. But for example, Anon, a person in India, tells us another story. For example, his parents only consume internet through their smartphone, and he himself has a laptop and connects via Wi-Fi to the internet. And opening Gmail in basic HTML takes 30 seconds to a minute to load, and this is unexpected. And he says Google also optimizes a lot for slow connections, so that definitely helps him. But 30 seconds to 1 minute is crazy. So when we develop a website or a web application, we have to think for which target audience we build this website. And here you have a page where you can see that the web isn't experienced the same way everywhere. And I want to show. Okay, can I? Yeah. I want to show you two very different countries. One extreme is Afghanistan. And you see, for example, the fixed broadband subscriptions is around 1,500. And here you can see the fixed broadband subscriptions in Austria is 2.4 million. There is quite some interesting data. It's insane how much difference there is between countries around the world. So, perfect. So how do we actually measure performance? You shouldn't think about page weight when it comes to performance, because Netflix or Facebook are really big websites, but overall they don't have really problems with performance just because they have a big page weight. Overall, the number of requests are also not really a good metric to measure performance. We come closer when we think, when is a web page actually, for me, fully loaded? But to be honest, would you be happy that after 8 seconds you see all of a sudden the whole web page loading? I don't think so. A good metric would be the speed index. This means how fast was the user experience overall. This means when can I first interact with the website or see stuff happening on the page. And you can see quite a nice difference here. On the right side, the user is happy because he sees already after around half a second that something is happening on the screen, quite a lot. But the left user has to wait 2 seconds until something is even appearing on the screen. So that's quite interesting. What tools did we use to measure performance during the workshop with Harry Roberts? First, I think every one of you know in the Chrome inspector, the Network Performance and Audits tab. And we used, like, for 5 hours straight, the webpagetest.org tool, where we analyzed, I think, for every person who was in the web shop, like 30 minutes straight websites. But this is the part which Tijana would have showed you, so I will not go into detail how webpage test works. When it comes to performance, we have to think about network performance. So I will show you how you measure how you can measure network performance. Overall, we're bound by physical and fundamental constraints. There is little we can do about constraints that happen when it comes to network performance. Nonetheless, there are some possibilities to justify the performance to our needs. So which are constraints which hinder us when it comes to web performance over the network? First, there is latency, which means how fast can the request go to the server and the server respond back to the user. And then there is bandwidth, which means how much data can we carry on that whole journey. And quite an interesting thing for me to know is that bandwidth makes little to no difference for the average internet user, and that slow load times are more strongly related to network delays, aka latency. Bandwidth just matters when you really have to load very big pictures or stream videos, but it doesn't matter when it comes to a small amount of CSS or JavaScript. Their latency is a bigger factor when it comes to performance. And we sometimes think, okay, latency, what happens when a request goes to the server and a response comes back? Overall, you can see it's quite a journey, because first you have to do the DNS lookup, where you map a domain name to an IP address. Then there could be a TLS negotiation for a secure connection, and you could do domain sharding, meaning connecting to more servers. And you see that each part of this network connection needs some time, and this is time you need actually for performance. What I really liked about Harry Roberts' workshop was he in detail explained to us the difference between HTTP 1 versus HTTP 2. How much of you do you think know about the difference? Does anybody know? Okay, so I will tell you something about it. HTTP is overall a protocol which exchanges information between a client computer and a local or remote web server. And with HTTP 1.1, it was possible to send multiple requests over one TCP connection, but it was limited to 6 to 8 requests. HTTP 1.1 was also able to do pipelining and cache control. When it comes to HTTP 2, it requires HTTPS, and it's also backward compatible to HTTP 1.1. This means it can everything that basically this HTTP version can also do, but it comes with a lot of improvements in speed. First, there is the compression of request headers. Then you have the server push. Then there's the request multiplexing over a single TCP connection, and it has also better caching strategies. I know a lot of weird stuff happening. What does it mean? So when you use server push, normally when you want to request the index.html file, you get this from the server back. And when, for example, the style CSS is also in the index.html file, the browser first has to parse this document, and then when it finds the style CSS file, sends another request to the browser. When you actually use server push, it doesn't have to take the second round trip time, because you can just say, please push also the style CSS, which is included in the index.html, with the first response to the browser. Then you got both without doing a second request. So this is quite practical. Also, I talked about request multiplexing, and here you can see what this actually is. With HTTP 1.1, you had the problem that when you make a TCP connection, you can just download in parallel 6 connections at a time. You had to wait until they were all done, and then you had to make another TCP connection and load the next 6 resources, and so on and so on. And what HTTP HTTP 2 makes better is that you can reduce additional round-trip time and make your website load faster, because you just have to connect one time per TCP, and then can request all resources you want at one time. This is really a nice URL, or you find here a lot of resources when it comes to high-performance browser networking. I can really recommend, when you're interested in a network performance, that you take a look at it. It's really interesting. So next would be render blocking assets. Some assets block rendering, means the users see nothing until all these resources arrive. This means we need to get these assets over the wire immediately. So to make the performance faster, please check your needed resources, eliminate what you don't need, and mark resources, for example, your JavaScript as async, or increase their priority. What are render blocking resources? First, we have HTML and CSS. So it's important that you optimize these. JavaScript is also render blocking, but it's not render blocking when you mark them as async or defer scripts. This is really important. And not blocking are images and fonts. Here you can see why HTML and CSS is indeed render blocking, because when you would start rendering without loading the HTML, there would nothing be on your screen. You need a DOM to render, so you need the HTML beforehand. And also with CSS, when you start rendering the page and you don't have CSS but the HTML, you would have such a page which you couldn't really use. So how do I identify critical resources? There is a coverage tab of the DevTools available, and you can see here that the red resources are styles that apply to the content not immediately visible and code not being used in the page's core functionality. And the green stuff are assets that are required for the first paint. So you can look up which resources you could maybe load asynchronously. Now I want to also talk about the 3 C's, because concatenation, compression, and caching are also very important when it comes to web performance. Concatenation was used to avoid the parallelization issue with HTTP 1, and this means to transport as few files as possible over the wire. This means to concatenate your files. But actually this should be avoided with HTTP 2. And I can give you the tip to break your files into high and low rate of change bundles, because when you have low rate of change bundles, they don't change frequently, and you can cache those bundles better because they don't change. Large single files get overall better compression than many small ones. And overall, you should, with HTTP 2, send 6 to 10 packages over to the server. Then compression is also a really interesting part when it comes to performance. Compression saves overall a lot of data with little effort. You have to take into consideration that you should just compress text files and not binary files, because binary files like images are already compressed. Types of compression are, for example, gzip, very well known. Then there is a new one called Brotli. It's a new open source lossless data format, and it overall gets you better results than gzip, especially when it comes to CSS, JavaScript, and HTML files. But you shouldn't use it too often because it has a slower compression speed than gzip. And then there is caching. Caching stops the client having to go back to the server, and overall the best request is the one that doesn't happen. So don't rely on caching, make use of it, but don't assume it's always on your side. Why? Because devices just have finite storage limits, and browsers drop things from the cache whenever they feel like it. Really interesting for me was, as Harry Roberts told us about resource hints. Who of you actually heard about resource hints when it comes to performance? It actually looked like this also in our workshop, so don't worry about it. Resource hints is a way to tell a browser what's likely to happen in the future, or what resource you will get likely in the future. Browsers can factor that into its choice for how it loads this resource, and it's very easy to implement. It's a single-line addition to prompt early activity, and all these resource hints you see down here use the rel attribute of the link element. And I want to go more in detail just at the preloading event resource hint, because it would take another presentation to go into detail of all of them. So when it comes to preloading, this tells the browser about an important asset without delaying the page's onload event. That means when you load a resource with preload, it is not render blocking anymore. The as attribute at the preloading tag tells the browser what type of resource will be downloaded, so it can be handled then correctly. Preloading should be used for assets that are above the full content. So, for example, images or fonts the user sees immediately. And the resource is loaded with the same priority as it would otherwise, but now the browser knows about it ahead of time, allowing for the download to start earlier. And when you preload things, please also use this resource in your code, because it would be extra performance if you wouldn't use this loaded resource. For example, you can see the difference of using preload here at the Shopify's page. They switched to preloading web fonts and saw a 50% improvement in time to text paint on Chrome desktop. And this removed the flash of invisible text completely. As you can see, it's rather easy to implement, but I think they also did preload their images they had above the fold. Then there is another quite interesting thing I didn't know about. It's called priority hints. And priority hints set the importance of a resource to prioritize downloading it sooner or later. So you have more flexibility by telling, please give this importance low, or please give this resource importance high. And currently, web developers have very little control over the importance of loaded resources, other than speeding up the discovery by using preload, like I told you. Priorities depend also on the type of resource you load. For example, script will load faster than an image, which is not render blocking, etc., and the location of the reference in the document. And this priority hints work on image tags, link tags, and the fetch functionality of JavaScript. This looks like this. For example, when you include a carousel, you want to show, of course, the first picture to the user, because this is what he immediately sees. So you give this importance high, and the other one's an importance low, for example. And here you see two different scripts. And here, the user wants to load the homepage.js first, and then afterwards the chat.js with the importance tag. And you have to also see he tries to preload this asset asynchronously, so it's not render blocking. What do we do when it comes to CSS and performance? We already know that CSS is one of your biggest performance bottlenecks. Why? Because it is render blocking, like I already said. Your page will only render as quickly as your slowest style sheet overall. So this means get your CSS over the wire as soon as possible. Means just send as few files as possible. They should be as small as possible. And the browser gives overall the CSS already a high priority. Leave it by that. An overall good tip is to identify all of the styles needed for start render, which happens above the fold, inline them in style tags in the head of your document, and asynchronously load the remaining style sheets of the critical path. You want to make this especially with HTTP 1.1, because you don't have the server push, which helps you. Another interesting function how you can load your CSS asynchronously is with media types. You can split styles into different files organized by those media queries, and the browser will still download all the CSS files, but it will only block rendering on files needed to fulfill the current context. And the current context is the context which you write into the media attribute. And there is also a really interesting hack how you can load CSS asynchronously in the whole document that you can see here. You give it a really strange media query that doesn't exist, but it will, like I said, download those files nonetheless. And at the onload attribute, you set this media to all. How do we deal with JavaScript? JavaScript is also, like CSS, a very expensive part of our site. Overall, the user does not only want to see the UI fast, we also want to interact with it fast. And I think we all know the problem when JavaScript is blocking the main thread and nothing else happens on it. So overall, there are more problems going on with the download and execution time. Those are the primary bottlenecks when it comes to JavaScript. Parsing time is pretty good in overall the browsers. You should use async and defer scripts. Those get parsed on a separate thread, and you can, when you write async and defer, you can load them asynchronously in the background, so your JavaScript is not blocking the thread. To see how this actually looks like when HTML is rendering, you see when you include a regular script file, your HTML is parsing, and all of a sudden your JavaScript is downloading, and this blocks HTML from rendering, and also the executing of JavaScript is blocking the rendering of your JavaScript. This is a problem. Then when you include your script asynchronously, you can see that the download happens parallel to the parsing of your HTML. This is a good thing, but when it's finished downloading, it executes right on the moment, and this also blocks your HTML from parsing. And when you use this defer attribute, you can see your JavaScript downloads in parallel to your HTML, and after all your HTML got parsed, your JavaScript is executing without blocking the connection. So what are recommendations that Harry Roberts gave us for handling JavaScript? Reduce overall how much JavaScript you ship, only load resources the user needs for the current route. Avoid shipping large bundles and take advantage of HTTP2's parallelization. Avoid overall also large inline scripts. The code has to be parsed in the main thread, and this takes performance time. Also, like you said previously, put JS code that is not frequently changing into separate vendor bundles, because you can get a lot of caching benefit right here. And on mobile, you'll want to ship overall less script because you have worse CPU and your latency is also quite bad. Which tools can I use to make overall big imports visible? I think some of you maybe know about Webpack Analyzer. I used it myself. It's quite neat. Here you can see Webpack Analyzer seeing that you use huge Lodash.js bundle, which you don't actually need all functionality of. And when you use the Lodash Webpack plugin, you can actually tree shake this huge bundle and just use functionality you actually need and import them on their own. To sum up my presentation, a lot of today's best practices will become anti-patterns in the future. You saw it with the differences about HTTP1 and HTTP2, and this will happen also with performance in the future. And I can recommend you, when you want to keep up to date and go in detail about web performance, this resource, Smashing Magazine, does a great job at actualizing its front-end performance checklist. So thank you.